Okay, thank you very much, Richard, and I'd like to thank every one of you for coming, friend or foe alike, especially some of our friends from the News Journal who've taken the time to come here and listen to what we have to say, which I appreciate. Well, I'm going to tell you the story about sea level change. My part of it will be to cover something what they call the global, which means you average over the globe. Imagine all the waves in the oceans going up and down, and you're trying to make this kind of measurements to determine what the global average sea level is. But before I start, I better make a disclaimer because I come here as an independent scientist. I apologize for the redundancy, but these days you apparently have a lot of scientists who are somewhat not independent, which means they sort of base their view and research agenda on, the funding, research structure, so on and so forth. You can call myself to be the lucky few who really do not care about career nor funding prospect. All I care about is to present scientific truth. So this is why I have to start with this chart. This is a serious disclaimer. This is definitely not my house. This is my cousin Oprah's house. If you don't believe me, I have been accused of such wealth, okay? So just take a look at this particular quote. There are people who claiming me for having hidden payment for the Swiss bank account and saying that I've been taking dirty money from the meanest villain on earth in a plot to allow mass murder by weather chaos. Unbelievable. And I just want to correct one small little thing. I'm here all for the truth, nothing but the truth. Half truth is not good enough. Half truth is essentially lies, so I'm not going for that. So I'm just going to tell you what I understand. There's one more important thing. You're never ever going to believe what I say. You just have to learn these facts and then try to study the issue more in depth for yourself. After all, this is the only way you can understand the subject. The subject can be a bit complicated, but we shall do our best to make it easy to understand, of course. So as I say, I'm going to talk a bit about this issue about measuring global sea level, and then the claim that because humans have put out this carbon dioxide, the satanic gas, the well-known satanic gas, that they claim that we have put out this molecule that has one carbon and two oxygen molecules, that we are going to catastrophically, essentially we're going to raise fire in all our forests, we're going to kill all the polar bears, we're going to kill all the fish in the ocean, we're going to raise the sea level, so on and so forth. And all we need to do, remember, all we need to do is just cut down the human emission of CO2. Stop using fossil fuel. Call Fred Flintstone and tell him to stop using the coal and use the coal to knock on his head. Then it will solve the problem. So, you will hear about David talking about issues that's more directly on Delaware. But I'll start with this introductory chart by telling you about several of the key factors that can affect global sea level changes. One of the obvious ones will be to your far right, will be of course ice sheets, the amount of ice that was locked in the land, either in Greenland or Antarctica. Remember, sea ice doesn't affect sea level change, right? Because it's ice floating in the water, so look at your glass of water with ice, and you know that if it melted, it doesn't do anything, right? So it's that kind of ice that is very important if it melted or it's not melting. So we're going to try to look at the scientific evidence for that. And then another way that the sea could actually rise is basically the water get warmer, the ocean water get warmer, so warm water tends to expand a little bit more, cold water shrink. That's basically a very simple physics, but that happens. So that's another factor. And then the important one, which is much more difficult to study, is having to do with the circulation itself in the ocean. And then there are also factors that is really relevant for Delaware. It has something to do with the land movement, the coastal zone, and how much of the sediment you put out, so on and so forth. I mean, there are even stories for Delaware that will go back 21,000 years at least, and Professor Legates will explain to you the reason. And then there are also, of course, the important component of water that is being stored in the land, right? By either groundwater and that sort of thing, that we use up groundwater in urbanization processes. There are significant impacts of such things that one can observe in certain regions. In Australia, for example, they've been draining the groundwater a lot, so It's clearly that they've been using the water and then dump it into the ocean, so most of the sea level rise that you kind of observe there can be explained by even such signals. So that's the kind of a story that one has to be careful to look at each individual region. So let me start by this sort of somewhat surprising chart. Here's a historical best estimate of what the sea level change has been for the past 1800 years. Are you surprised? Do you guys see any major sea level change in the 20th century? I'm not cutting that off for a purpose. I just want to compare to you what the measurements and best estimate of the sea level rise globally average for the last 1800 years or so. You can see that sea level has been, going down and going up for about that long that we have reasonable estimates. And then let's focus on the most recent period. The most recent period, as is always played in the game, is very well known and is being played by basically what the United Nations Intergovernmental Panel on Climate Change, called the IPCC. Please, just to judge, how many people know what IPCC is? Okay, very good. At least a substantial amount of you know about that. This is the United Nations group that supposedly trying to put out the best possible science. But I have to tell you that in my humble opinion, they are basically a very, I would say maybe the good word to say that they're a very sick group. They are very ill because they're not talking about science at all. It's always about agenda-driven scientific results that is somewhat exaggerated. So this is one of the examples that they try to present to you, the case of sea level change for the last 250 years or so. And they added 100 years into the future, of course. And same thing for Delaware, which you will observe, because they say if the sea level don't rise that much now, but then for the next 100 years, my God, it's going to go up, 1,000 millimeters. There's a lot of it, okay? You can convert it to inches and all that, I don't care, but I just think that those curves are not valid, and I'll try to explain why. Okay? But apparently, according to IPCC, by the way, I'm reporting the most recent result that will come out in September. So we do have a bit of a preview here, preempting about what we already can see, what is promising from IPCC for the next 6 months or so. Another one of this quote that is somewhat interesting, that even such a finding that they say they have found the sea level have accelerated, not in year 2000, but accelerated in year 1900, where the level of CO2 actually has been kind of small, that is contributed by human. So supposedly even that is supposed to be scary. All you have to do is use the word acceleration. But I want you to be aware that they are pointing at the wrong places for now. Okay? So that kind of conclusion is also available in the scientific report. So that's what I mean. Is this really that all scary? What are the facts? Let's take a careful look at this situation and see how do the scientists go about doing this. By the way, it is also a bit of a career business now to try to project what the sea level change could be. You understand the argument is that if we try to measure the ocean now, if we cannot even find that the ocean is warming very, very much, that it causes significant sea level change, all we have to do is to say that, well, don't worry about that, we have the ice sheets. There's a lot of water there, so all the ice sheets melted away. So in this scenario, this person from New York City, Professor Jim Hansen, he's working for NASA, Goddard Institute for Space Study. He's actually proposing that the sea level for 2100, not what the IPCC is saying, which will rise by 1 meter, which is about 3.3 feet. He said that it could rise by 16 feet. Okay? And that's what the example that they show, Florida will be completely gone. By the way, please, someone please tell me, are you scared about a picture like this? I cannot say, what kind of picture is this? This is really a cartoon. By the way, he probably learned this from Mr. Gore himself. Sometimes I'm confused when I look at the literature. Who is actually doing what? You see that the same exact number talking about New York City and talking about the World Trade Center Memorial is going to be underwater. 5 meters, okay? They're talking about same numbers. So somehow we have a bit of a confusion about whether politics leading science or science leading politics or informing the policy decision, which is a very unfortunate situation. And then this is what I tried to point out to you about, and then there is also a golden prize. Apparently among some of these scientists, that they even argue that whether the curve that going to 4 meter changes, which is about 16 feet, It's going to be done by this curve or done by that curve. According to Professor Hansen, his scenario is more correct because he said that, well, we will never see the sea level change for now for the next 80 years, but then wait till 2080. This is what you're going to get. When you reach 2080, the curve is going to accelerate and zoom out. And you're going to get something like 4,000 millimeters in 20 years. You know what? That is equivalent to 200 millimeters per year. That is huge amount of sea level rise if we're ever going to be able to see this. In fact, today, the best measurements, we don't find anywhere on planet Earth that rising at more than basically 2, 3 the most, you know, or 4 or 5. There's nowhere near 200 millimeters per year kind of changes. This is the kind of scenario that these people are proposing you to be taken seriously because they say if you don't cut the carbon dioxide emission, the curve is going to go that way. So this is the way you should look at Delaware. Goodbye, Delaware. So you guys are not going to have much Delaware left. Please buy more inland property so maybe you can make some money from Al Gore himself. And if you don't believe me, these people are very serious fear-mongering. They're professional. Take it seriously from me. I mean, this is from United Nations Environmental Program. Do you guys know that in October 2005, they actually predicted by 2010, what year are we in now? That there are 50 million refugees that you should get. If you look carefully, of course, the US East Coast is among the vulnerable one, probably from sea level rise according to their picture. If that is not enough, remember they published it in 2005, and of course 2010 came along, there's no 50 million refugees. By the way, did we see any newspaper, even in news journal, reporting about 50 million refugees? I guess not, right? But guess what? They never learn, these people, because their only strategy is to keep going. So by 2011, February 21, you see the same statement. Now, instead of 2010, now they move another 10 years ahead. So 2020. I guess they never learn anything, do they? Right? So indeed, the theme of my talk, now I'll get to the brief of the presentation, which is a long, hard work, but I hope that some of the science will enchant you. It's a difficult science, by the way. It's very complicated, but I'll do my best to explain to you why. This is truly bad science. This kind of report, the curve that they're drawing, and including the one that's going to produce by Denrek, will be explained by Professor Legates, about how the future is Delaware going to rise by 1 meter or 1.5 meter. It's completely impossible. In fact, if they're willing to take a bet, let's take a bet too. I'm willing to do that too, but scientists is not a good thing to try to make any bet unless you know what the science is. This is terrible science. This is not science actually. This is, and I might as well ask my two little boy to draw any line they want as far as possible towards the future, which is not a good way to talk about science. So here's the picture. The standard picture that tries to tell you about global sea level measurement is indeed like this. From about 1800 to 1920, we have some low level of changes by 0.88 per year, the rate of change. Then they say by 1920, going to about 1980, the rate started to go up, about 2 millimeters per year. And then they say, look, at the latest, we must be suffering from global sea level acceleration. This is the usual picture, okay? That by about 1980 onwards, 1990 onwards, that you're going at a rate of 3.2 millimeters per year. In science, indeed, if this were to be true, you call this acceleration. But I have to tell you, let's look very carefully in the most recent measurement, which we have the most accurate data. Let's examine what this measurement is all about. It's done by satellite measurements, but I have to inform to you that bad news for those scientists. By the way, of course, at this rate, you know, even the shark don't have to do anything because in 5 years they will get to eat the guys fishing over there. That's not me, of course. So the really primary assumption that I want to point out, bad assumption. In science, you can make all kinds of assumptions. The real whole question is how good is your assumption? Can that be justified by any physical reasoning or physical evidence? And that's very, very important. And I want to tell you that the statement that you can make that kind of sea level, global sea level measurement using satellite, okay, is called an altimetry measurement, meaning just trying to measure altitude from satellites, okay? Using radar, basically you shoot radar, you try to watch the wave bounce back to try to detect
how high the wave height is over the whole ocean. It's a very difficult measurement, okay? And it's roughly represented by this kind of picture, showing you how the satellite orbiting the Earth is able to send out this radar in microwave region, just like the microwave in your microwave machines, sending out those things and then trying to detect the level of sea level height, okay? And measure all over the globe. It's a very ambitious task, okay? And there are a lot of details, but they're not so relevant for discussion here. But the main point is that they have made this kind of attempt to make measurements. And since 1993, we have had about 6 different satellites doing this kind of measurements, okay? The data that they show you is basically from a combination of 3 satellites, which I will discuss next. By the way, sea level acceleration. Do you guys see that the sea level acceleration now, if you follow just the blue curve, is somewhat true, the one that say about 3 millimeters per year from 1993 to 2008. But actually in published paper, they actually found that over the last few years, I would say from about 2004 or so, that the rate has turned into 1 millimeter per year. So what's going on here? Maybe they have sea level deceleration rather than acceleration, isn't it? After all, this is a peer-reviewed published paper. One should take this seriously. And there is another proof. From about 2005 to 2012, have all the data we have available, the most updated information. Can you guys tell me that this sea level change is still very scary or not? It's actually flattened out quite a bit. Okay? And then, of course, my job now is to explain to you that even that data, even that value, the most recent measurement, at the top of the thing, say Jason 1 and Jason 2, total sea level rise of 1.6 millimeter per year. Even that number, I don't think you should trust it. Science is not about trust, it's about verification. It's about how you can verify your number. And now let me point out. The most important thing I want to add to this discussion is basically point to you this very significant project that has been started since 1999, but then we have the most recent measurement, the most global measurement starting about 2003. As you can see by now, we have about 3,600 of this float that is floating on the top of the oceans and then go down into the depth of the ocean by about 2,000 meters and then come back up in about 10-day cycle and then send the information to the satellite where we can collect them. We have had that kind of global measurements since 2003. And this is a very significant scientific project. By the way, the reason why I want to point out this result is this. Do you guys know that if you measure temperature in this room, you will get about 1,000 different numbers from the temperature here to the temperature at the back of the room or the temperature near the drinks and so on and so forth. Temperature is not a very interesting quantity to measure. The one that is being measured here is called the ocean heat content, which means we are able to measure the actual heat content that is available in this volume of gas or water. And that is very significant. Because if you ask yourself, if you measure 1 pot of boiling water, what is the temperature? It's boiling. But then if you measure 2 pots of hot boiling water, you actually have 2 times the amount of the heat content in it. So that measurement is very, very important. And the prediction from the CO2 global warming theory is that they say that the heat from the CO2 infrared radiation, which means from the greenhouse effect of the CO2, has been accumulating in the ocean. Okay? And it's been accumulating for a long time. And if we were to be able to find the impact of the CO2 on the ocean, we should be able to find it in the ocean heat content measurements. And here's the results. Sorry for the wrong introduction, because this is a very important test for science. So as you can see now, the blue curve showing you the actual measurement of the ocean heat content from 2003 to 2013 or so. It's more or less going up and down, almost no trend. And then if you ask yourself, what does the model actually predict? And in science, maybe you all have heard about what Professor Albert Einstein has said. No amount of experimentation could prove me right. One single experiment could prove you wrong. Okay? And that is very important lessons about science. It doesn't remember if you're a member Academy of Science or not. It's just how good is your measurement. Okay? How good is your theory? And in this particular scenario, I would say that they are in a very bad situation to try to say that the ocean is caused by, the sea level change is caused by heating up of the ocean, because the ocean is not heating up that much. Okay? And we have very accurate measurements now, to the point where we can reject hypothesis, which is really, really very, very significant challenge to the CO2 global warming idea. And now I want to point out the raw satellite data for this sea level height. As I told you, you have 3 sets of data, the TOPEX, JSON 1 and JSON 2. And look at what happened when you measure them without any correction. That's what the level is. And you want to see what the author of this paper say? Look, we try our best to measure the sea level height, the global sea level height. And we don't know where the global sea level is at, essentially telling you. So this is why, between all these satellites, they have this kind of biases of 100 millimeter, of 75 millimeter, and they are trying to tell you that they can detect a change of 3 millimeter per year. Okay? And even more important information is basically that between TOPEX and JSON 1, you have actually the 2 satellites co-flying at the same time to try to get the calibration correct. And they're within 60 seconds of each other. And the altimeter, the instrument that they have, is almost the exact identical one. And they couldn't even get the level up to 100 millimeter. Sorry for torturing you through this chart, but this is very important. It pointed out why the satellite data is not reliable at all. They have had some significant problem in the measurements. So if you ask yourself, could this be only one-time problem between these 3 sets of data? Obviously the answer is not, in my view, because I found out that there's another satellite that they're measuring. This one, it takes a bit of looking for your part, I'm sorry. So please focus on the yellow curve on the other chart that dated February 8, 2022. It's the one that labeled NVSat. This one. Can you guys see the curve? And look at in February 8, 2012, it was kind of flat. But in January 24, if you download the same data sets, it turns straight. It follows everybody's line. This is basically saying that if the measurement did not agree with this consensus point of view, by the way, consensus is not science, of course. We got to fix it. We got to make sure that they agree with each other. Okay? After all, we have all these other measurements agreeing with each other, which is not true, as you can see. They're not even close. So this NVSat, to me, is another disappointment in the measurements. It cost about 2.3 billion euros. It was launched on March 1st, 2002 to April 8, 2012. So it's close to 10 years of investment. And look at what happened. They actually got the raw data, which is the black dotted curve, that measure that global sea level change is only about 0.5 millimeter per year. Remember, they're talking that it should be 3 millimeter a year. That's 6 times bigger than what is actually being measured in raw value. And then they show that the JSON 1 is pointing something like 2 to 3. Okay? So what happened when they see this? They actually say, oh, we got to correct the NVSat data so that they agree with each other. Believe me, if you have a good reasoning to explain that, I will humbly accept it. Because that's the way science works. You can have measurement problem, you can demonstrate some of this. But the problem is that if you dig very, very deep, you will find out that the essential explanation is that we don't know. We don't know how to measure the absolute level of sea level correctly. That's why they have the sea level, the 2 satellites that fly around within 60 seconds of each other couldn't measure the same numbers. That's how hard the measurement is. Because it's meaningless what they're chasing. This is where the adjusted versus unadjusted value is. Okay? So the bottom line then tells you that this data has been completely manipulated. The one that says that you have sea level acceleration near the end of 20th century. You know, the one that on the right here, on April 10th. Look, within 4 days, even the data set could change. This is the kind of a detection that I work very hard through some of my colleagues that were able to detect, document what has been changing. And if you look carefully, they don't explain anything. They just say, take our value, trust me. By the way, please, can anybody tell me the science work like that? Does it ever work that, trust me, here's my data. You're not smart enough to think. You know, you average people, you don't know anything. You know, I am one of those who really don't trust anybody. I don't even trust myself, okay? I check everything. And that's the way it works. But look at what they're giving you. So I'm trying to tell you that they have a serious measurement problem. By the way, if you think that I'm only here to propose to you that the low level of sea level change between anything from 0.5 to 1 millimeter per year is the only legitimate value, please look at some of the O value when they didn't correct for anything. It was O value, 0.5. I traced in the O measurement. Then how come all of a sudden everything had to go up to about 3? Remember, going from 0.5 to 3 is factor of 6, which is 600%. Guys, this is very serious measurement problem. And of course, funding keep continuing because we don't understand enough, so keep paying us. The next one is that I can show you slightly updated, but we try to adjust it up a little bit, so it's 0.9. But still, trying to tell you that the past value that's slightly not corrected has been very low value. Now I want to point out another problem. You all have heard that they say that the ice sheet has melted. Greenland ice sheet has melted, even Antarctic ice sheet, especially the western Antarctic ice sheet has been melting. So therefore, it's dumping a lot of water into the ocean, correct? That's what they've been claiming. Therefore, they have this particular project called GRACE. Very nice name. Okay, it's actually a gravity measurement of the planet Earth. Okay, it's a very sensitive measurement with 2 simultaneously floating satellites. Because of gravity pulling the one ahead a little bit more than the one behind, and they have very accurate calibration of the distance between these 2 satellites, so they can measure very, very precise gravity perturbation, gravity control on the satellite height and altitude. Guess what they got? When they measure the thing, since 2003, they actually got this data. This measurement is telling you that the world ocean has not added more water from melted ice. It's actually losing more water. It's basically essentially telling you that perhaps the ocean evaporated more. Probably related to some other warming during earlier period. Probably other factors. And then another crucial fact about this is that the world ocean, if you look at the best data for measuring salty content, salinity, it's actually shown that the world ocean has been getting more salty. Remember, if you were to throw a lot of water from this melted ice sheet, guess what the ocean should be doing? Should you be more salty or fresher? Should be fresher, isn't it? But the ocean says that it's actually more salty, which means it agrees with this raw data of the GRACE measurements. But then they say no, because we know that the altimeter data could not be wrong, the one that says about 3 millimeters, so we have to correct for it. So we add this is where the correction is. Okay? And it's very, very hard to find this particular curve, by the way. It takes a huge amount of detective work to find this sort of thing and try to clarify and understand what the issue is all about. If you don't believe me, here is another way of another serious scientist who try to look at the GRACE raw data without any correction yet. That they show consistently is either decrease, which means the world ocean is not adding more water from the runoff from the water, from either from the river or from the ice sheets actually. Nothing is added more, which means you are losing more water. So how can sea level be rising when your sea level is actually decreasing? This is the puzzle. By the way, these particular scientists have a way to explain this, which Professor Legates will mention a little bit more details. I hope that most of you know that the Earth in 21,000 years ago, Delaware, you are kind of lucky because you are at the margin where the ice sheet was so big in North America. Main center is in Hudson Bay, of course. The ice sheet could be almost 2 miles thick, so 3 miles thick. And then the ice sheets, of course, cover Boston, New York, New Jersey, but it didn't cover Delaware. You guys are at the margin. Well, none of you were born at that time, of course, 1,000 years ago. But these scientists explain that the reason why you must correct for this lowering of sea level to high sea level, you know how he explained it? He said because those amount of ice added so much weight that you actually dump all the water into the ocean. That is true because the water had nowhere to go. That it added so much weight that your volume, your swimming pool has been getting larger. You understand what I'm saying? They say it's been pushing up, it's changing the shape of the ocean basin. The ocean has been getting expanded and getting larger. And therefore we must correct for it because the sea level is actually rising. But if you think about it, how does that work? The measurement is still saying that the ocean is not getting more water, no matter how you argue or hand wave about this. This is where the problem of all this world experts that's been talking about things like that somehow also elude me. I wish to be enchanted by this kind of argument. So, this is the kind of quote from Professor Peltier. He said that as far as the raw data is concerned, remember, he totally believed in this CO2 global warming issue. This is why he worked so hard to try to show you that the GRACE data is wrong. It must be corrected. And he said, but then he said, the raw data is concerned over the entire area of the global ocean. There is no increase in the mass. There's no increase in mass from the melted ice sheets. But it's actually decreasing, which is really, really somewhat of a negative news. So for people who really worry about melted ice sheets, I'm sorry, you don't even have evidence to go for it. That alone melting, you don't even see it. You're seeing that water is actually decreasing from the oceans. So my conclusion for this part of the talk is that there is a failed science experiment that is shown by this series of altimetry measurement, which is trying to measure the height of the ocean wave, and also the gravity measurements, and they have no reliable calibration. Okay? And I really find this to be a very exciting actually for science, which means that you have more to learn, by the way. Which means that this kind of stuff ought to be fully communicated with and discussed with a lot of these major scientists. I'm just a humble scientist who look at this issue independently. And I wish to be corrected if I'm wrong on any aspect of it. This is the way science works. And there's nothing to be ashamed of. Okay? And then, if you don't trust me, by the way, if you ask who is the most, I guess, credible and well-known oceanographer in the living world today, it will be this professor. His name is Carl Wunsch from MIT. He totally believes in CO2 causing global warming. But then, please read what he says about these satellite altimetry measurements of global sea level rise. He said it remains possible that the database, the satellite altimetry database, is insufficient to compute mean sea level trend with the accuracy necessary to discuss the impact of global warming. And for scientists, it's very difficult to say this, as disappointing as this conclusion may be. Which means essentially him, aka in plain language, they have had failed scientific experiment. It's an ambitious task. I don't want to devalue their great effort, but then in science, I'm sorry, you can cry all about it. If you're not making the right measurements, you're not making the right measurement. There's no if or but about this. So please allow me to be bold by making this kind of conclusion. And then, this is my bottom line, which I borrow from my colleague Niklas Mona from Stockholm University. He is the world premier sea level expert. The essential conclusion is that I do not think that the world global ocean is rising at a rate from 0 to 1. All this high value, as I pointed out to you, by satellite altimetry or some of this modeling, including the one from Professor Peltier, it's all theoretical values. They are just either wrong or that kind of thing. I do not believe, in fact, even IPCC estimates in the early days was showing that the sea level was less than 1 millimeter per year. And we will say a little bit more about what happened in Delaware. So the bottom line is this. If you assume very, very generously that if you are really concerned and being conservative, that you have a rise of a rate of 1 millimeter per year, guess how many inches is that? 4 inches in 100 years. I will finish now, but then I want to say that all this assumption about 1 foot to 3 foot sea level rise is just greatly exaggerated. I'll finish this one thought. I once heard a comedian that says that, you know, if the sea level is rising at a rate of 4 inches in 100 years and you don't know how to move backwards, you deserve to die.